Although galaxies are big, there are bigger recognizable structures in the observable universe. The Milky Way is a member of what is called the Local Group. It is a grouping of galaxies, all gravitationally bound to each other, that is about 10 million light-years across. It consists of 30 galaxies. As a general rule, spiral galaxies tend to be the dominant members of groups. As mentioned in the video on galaxy types, giant elliptical galaxies tend to be the dominant members of larger gravitationally bound groupings of galaxies called clusters. Galaxies can be members of either a group or a cluster. The local group is a member of an even larger gravitationally bound grouping called the Virgo supercluster. The supercluster is about 200 million light-years across and contains 100 groups and clusters or about 10,000 galaxies. There is structure at even larger scales. That structure isn't isolated but rather woven together into a web or foam-like structure. Shown is astrophysicist Margaret Geller's mapping of galaxies out to 700 million light-years. To her surprise, galaxies weren't sprinkled uniformly throughout the universe. Instead they lie along sheets or filaments, leaving large void spaces. At even larger scales, this structure persists. Shown is a mapping out to 2 billion light-years. There are 100,000 galaxies mapped here. Like Geller's map, the Milky Way is at the center. Note that the number of galaxies tends to taper off as one gets farther out. This is due to these regions being so far away and our having less data. It has nothing to do with the actual number of galaxies at those distant regions. Data taken in different directions in space produce similar mappings. What gives rise to this kind of structure? Why is this structure so consistent everywhere? On the other hand, why is there structure at all? Why isn't there just a uniform distribution of hydrogen and helium? These are important questions that will be addressed later in the unit. Studies of the large-scale structure of the observable universe has given rise to cosmological principles. We will make some reasonable assumptions about the universe, which may be incorrect, but seem to be correct based on all our observations throughout the history of astronomy. We will assume that the same laws of physics apply everywhere in the universe for all times. If this weren't correct, it may be impossible to ever figure out the history, the fate and the large-scale structure of the universe. We will assume that we occupy no special place in the universe. The whole history of astronomy has shown us over and over that our planet, and all the objects that we are a part of, are similar to countless other objects. For example, the Earth is just an ordinary rocky planet orbiting a typical star in an average spiral galaxy that is a member of an average group, etc. Based on these assumptions, we have two cosmological principles. One is isotropy. This means that the universe looks the same in all directions. The other principle is homogeneity. This means that no matter where you put yourself, you will be among the same kinds of objects. Obviously, these principles hold only if one is discussing large enough scales. From the scale of myself sitting on the Earth's surface, the universe around me looks neither homogeneous nor isotropic. These principles are relevant on scales 100 million light-years or greater. Shown at the bottom are illustrations to help you digest these principles. Ignore the edges of the circles for this discussion. The illustration on the bottom left is isotropic, looking from center. However, it is not homogeneous. You could put yourself far enough out, you would be in the red region, rather than the blue region. The middle illustration is homogeneous. There are little stripes anywhere you place yourself. However, this illustration is not isotropic. In two directions you are looking right down rows and in other directions you are not. The last illustration is both homogeneous and isotropic. The view in every direction is the same, and in every place there are black specks.